All right, so today we're going to talk about the properties of operations. And it's a review from many other grades, but we need to remember that the properties of operations apply only to addition and multiplication. They don't apply ever to subtraction or division. So let's look at these four basic properties that we're going to review. The commutative property, remember the base word is commute, and if you think about commuters, they go back and forth, they just trade places. The same thing is true for our factors in a multiplication problem or our addends in an addition problem. So if you look at 3 times 4, if I just flip those factors around, the factors haven't changed. So the product isn't going to change either. 3 times 4 is 12, but if I change the order of those factors, 4 times 3, still 12. Same thing with addition. So commutative property is a property about order and the different order of your factors or addends. The associative property is just how you group your numbers. So again, you're starting with the same exact quantities. In addition, you have 7, you're adding 6, and you're adding 8. You just get to decide, well, which ones do I want to add first? Do I want to add the 7 and the 6 first? Or would I rather add 6 plus 8 first? I always look for the easiest one, the most friendly fact, and add that first. But since it's all addition and your addends haven't changed, the quantity is going to remain the same as well. The same is true for multiplication. Again, I have 7, 6, and 8, and I'm multiplying all three of those. So you just get to decide, well, would I rather do 7 times 6 first? Or do I like 6 times 8 first? Up to you. But either way, your product is going to end up the same. You see, I have SpongeBob and Patrick up there, and doesn't matter. It's kind of like your friends who you associate with. If at lunch one day you sit next to Patrick, but then the next day you sit next to whatever that snail's name is, I can't remember. But the three people haven't changed. So your identity property, I've got a mirror down there. Think about when you look in the mirror, you see an identical reflection of yourself. So for addition, the identity property tells us that anytime we add 0 to a number, we're going to get the same thing we started with. So the mirror here is 0. But in multiplication, my mirror is 1. Anytime I multiply a number by 1, my product is going to be the same number I started with. Identity properties, pretty easy. Okay, inverse property, got my shoes there. Remember how we talk about tying and untying? You do when you undo. That's what inverse means. So for addition, it's just any number and its opposite added together are going to equal 0. So a positive 3 and a negative 3 together, you're going to get 0. For multiplication and division, remember it's the reciprocal. When you multiply by a reciprocal, it's the same thing as dividing by a number. So remember how we talked about if I cut a candy bar into 2 equal pieces, each person gets half. So divide by 2 and multiply by 1/2. These two operations right here are exactly the same. So inverse of multiplication is division, and vice versa. Inverse of division is multiplication. Did I say that right? Distributive property, we talked about this earlier this school year. It's the same thing that you've been doing, just a fancy name for it, since you learned area models when you were probably in 3rd grade learning multiplication. All it's saying is that if you have a sum in a parentheses, you can, and a factor outside it, like this 8, here's the factor outside the parentheses. This tells me that I need 8 sets of 20 plus 4. So I can do 8 times 20, and then I can do 8 times 4, and if I add those together, I'm going to get the product for 8 times 24. Here's the area model for that. So I just broke up the 24 into 20 plus 4. That way I could easily multiply 8 times 20 is 160, and 8 times 4 is 32. When I put them together, I get 192. The distributive property, if you think about the word distribute, like if I ask you, distribute these papers to everybody in the class, you're going to take them from one pile and you're going to hand them out to make sure everybody gets a paper. So this 8 is being distributed. It means everything inside of these parentheses have to be multiplied times 8. So 8 has to be multiplied by 20, and 8 has to be multiplied times 4. When we distribute, we hand it out and make sure everybody gets some. We can also use subtraction to make it easier. So here we have the problem 8 times 98. Well, 8 times 98, I'm thinking, well, that's really close to 8 times 100. So I drew my area model of 8 times 100. Well, I know that's 800 right there. But I've got 2 groups too many. So 2 groups of 8 is 16. So if I just take that 16 out of there, I'm doing 800 minus 16, and I get 784. So my blue area there is 784. The distributive property just makes it easier for you to do your mental math. If you were going to find each of these products mentally, how would you break up that second factor? What would you do to find the product of each of these? For this one, we have 12 times 46. Use the distributive property to make each of these problems easier to share. Write them out using the distributive property. Remember, you need to have parentheses there because you're going to break one of your factors into a sum or a difference of 2 numbers. Okay, now what?